You've definitely seen this happen. You're walking outside on a sunny day, and as your shadow gets close to another one, say from a lamppost, it looks like it suddenly reaches out and snaps right onto it. It's this bizarre illusion people call the magnetic shadow effect. And trust me, the real reason it happens is not what you're thinking. Yeah, it really does feel like that, right? Like there's some invisible force, a magnet, pulling them together. Or maybe like the surface tension on water, where the two shadows just want to stick to each other before they even touch. But of course, that's impossible. Shadows aren't magnetic, and they definitely don't have surface tension. So, if it's not magnetism, what is it? What's causing this strange little blister that seems to grow out from one shadow to meet the other? What's the secret? Well, let's start with the obvious. With a name like the magnetic shadow effect, you'd be totally forgiven for thinking the answer has to involve actual magnets. And in real science, there are a few phenomena where magnetic fields do create something like a shadow. So maybe it's something really complex, like could it be these solar magnetic shadows related to the sun's own fields? Or maybe particle deflection, where a magnetic field can literally bend the path of charged particles. Or what about this one, the cosmic ray sun shadow? That one sounds pretty serious. Let's dig into that cosmic ray idea for a second, because it's genuinely fascinating. This is a real thing. High-energy particles are flying at us from all over the universe, all the time. But the sun's huge magnetic field can actually deflect them, creating a kind of void, a literal shadow in the stream of cosmic rays hitting Earth. It sounds like a perfect, if super complicated, explanation for what we see on the sidewalk. But it's not the right one, not even close. In fact, the real explanation for our everyday magnetic shadows is way, way more straightforward. And this is the brilliant part. It has absolutely positively nothing to do with magnets or particles or cosmic rays. The name is a complete misdirection. It's a total red herring. The real secret here isn't physics, it's geometry. Simple, if slightly weird, geometry. And it all boils down to the kind of light source that's casting the shadow in the first place. Okay, here's the key concept. A tiny, single point of light, like a tiny LED, creates perfectly sharp, crisp shadows. But the sun isn't a point. It's a big, extended disk of light up in the sky. So light is coming from all across its surface, from slightly different angles. And that is what gives shadows on Earth those fuzzy, blurry edges. That blurry edge is the secret to this whole illusion. So here's how it plays out. That blurry edge on the lamppost shadow, that's a half-shadow region, where some light from the sun is getting through. As your shadow gets close, you start by blocking just a little of that light, the light that's hitting the inner part of that fuzzy edge. And boom, a part of that blur suddenly goes completely dark. As you get closer, you block more and more of it. To our eyes, it looks exactly like the lamppost shadow is growing a little arm out to meet yours. And what's really cool is that this isn't just about shadows. This little geometric quirk applies to pretty much anything we see through a lens, whether it's our own eyes or a camera, whenever things are out of focus. If you're into photography, you already know this idea. It's called bokeh. It's that soft, blurry quality in the background of a photo. When a point of light is out of focus, it doesn't look like a point anymore, right? It spreads out into a little circle or a shape that's determined by the camera's lens. Well, that spreading out is the key. So if you focus your camera on something really close, an object in the background will seem to blister or grow towards it. Hey, you can try this right now. Just hold your finger up close to your face and focus on it. Now look at something in the distance, behind your finger. It feels like the background object is sort of reaching around your finger, doesn't it? That is the exact same geometric principle as the shadow effect. But here is the most powerful, absolute proof that this is just a trick of geometry and light. Let's imagine a little experiment. You take a green book and you hold it in front of an orange book. When you focus a camera too close, that green book in the front appears to grow a blister. And get this. That blister is orange. It's the color of the background object. It's not the green book growing at all. What you're actually seeing is a bizarre optical mirage, where a piece of the blurry orange background becomes visible in the space in front of the green book. Isn't that wild? So what we're all seeing isn't a force. It's not an attraction. It's simply our brain trying to interpret a very weird geometric interaction between an object, its background, and the way light travels from a big source or through a lens. And that's why this quote just says it all so perfectly. These blurry fingers and blurry shadows, they're not magnetic. It's just that the geometry of how we see the world and how shadows are cast is honestly just a little weirder than we think. And that leaves us with a really fascinating final thought. This whole thing is a powerful reminder that what our eyes see isn't always what's really there. It's just a trick of light and perception. And it really makes you wonder, if we can be fooled this easily by simple geometry, what else are we not seeing correctly?